Okay, so I'm going to show you how to do the examples using the graspable math. So we set it up for you guys for the same example, so you can go and follow through on that as well. And then we'll have some set up for the questions set up for the problems as well. So with the examples, okay, or with any of the problems, here are some problem-solving steps. It says make a list of known and unknown variables, write down the equation, substitute your numbers, and solve. So on the right-hand side here, the first example problem says you travel 60 meters to the right in 20 seconds. What is your velocity? So our variables are v, delta x, and t. Okay, and if you look on graspable math, I've set that up for you. The first three problems we've set up completely for you, and then we'll work on showing you how to set up the other two. So in this case, because we are looking for velocity, I'm not going to put velocity up here, but it is in our inventory, and we see that on the Google slide sheet. So in order to solve for this, the x is 60 meters. It's to the right, so it's positive 60, and then the time is 20 seconds. So to solve for this, we have to make sure that everything is that this is set to transform. So we click transform, and that will allow me to substitute my letters in into the problem. So I'm going to substitute my x into the x in the problem. Okay, I'm going to take my t, substitute my t in. There we go. And then to solve this, we have to get rid of the parentheses, and then we can then do the math. We have nothing but numbers and then one variable by itself, so we can just double click on the line, and that gives us our answer of 3. Okay. If we want to see every step, we can drag this down as well, so that way we can see every step. Okay. Next problem says an elephant travels six. Actually, before we get to that problem, let me go back and fill in my answer. Almost forgot. Okay. So our delta x in this case was 60 meters. Okay. Our time was 20 seconds. Okay. And since we just did our math on graspable math, the answer came out to be 3. And since it's a velocity, it is meters per second. Okay. Now we can go to the second problem. An elephant travels 60 meters to the left. So since it's to the left is a negative, negative direction. So we have x equals negative 60. And then the time is 20 seconds. So we have t equals 20. And now we can plug our numbers in. X goes in here. Our t goes in at the bottom. Okay. And I click to get rid of my parentheses. And then I can double click on my line to get my answer. So similar problem to the one before, only now because the direction was negative, it gave us a negative velocity as well. So I can go back, plug in my information here. This was negative 60 meters. The time was 20 seconds. And the velocity is negative 3 meters per second. Okay. And now to the third example. It says you run completely around a track, a 400-meter track in 80 seconds. What was your velocity? Really simple problem because your starting point and your ending point are exactly the same location. So our displacement in this case is 0. So when we plug this in, we get x is 0 and t is 80. And anything that divides 0 is going to wind up being 0 itself. So we take 0 divided by 80, and we get an answer of 0. So the velocity was 0. So plug that in. We've got delta x is 0. Time is 80 seconds. And our overall velocity is 0 meters per second. Okay, so now looking at the third example. It says a car travels 40 meters west. Okay, so that 40 meters is telling us that it's the displacement, and west is telling us that it's negative. So we can say that our displacement, our change in x, is 40 meters, negative 40 meters. Okay, we don't know what our time is. That's what we want to find. It says how long is the trip. So they want to know how long it takes. But the velocity is 20 meters per second west. And west is, just like with the 40, west is going to make it negative. So we've got negative 20 meters per second. Okay. So now we go back to the canvas. And if you notice, I did not put any information in here for you. So we have to plug it in ourselves. So in order to plug in what we have, we're going to go here and we click Math Expression. And in this case, our x is equal to negative 40. And our velocity is equal to negative 20. Okay. And just make sure that you use lowercase v for the velocity. So they're in kind of random spots, so I'm going to just move them so that they're nice and neat. Okay. And I did that by clicking Arrange and then moving them that way. Okay, and then I got to go back to transform to be able to do the problem. Now, the formula that we're using is the same formula for everything. So I can either rewrite it, or I could take this little circle here and I can actually drag it down to another problem, and it puts the formula there for me. So I kind of arrange that again. Okay, and then I hit transform to do the math. So now I just want to make sure I plug everything into the right location. So my x is going to go over top of my x. My v is going to go over top of my v. Okay, so now I click just to get rid of my parentheses. So now I've got to do some manipulating. Okay, we have a variable at the bottom of a fraction. Okay, whenever this happens, we have to move that variable out from there. And because it's negative 40 divided by t, we have to multiply both sides by t. So if I just take it with graspable math and I drag it over, I can see that it will allow me to multiply. It will not allow me to divide. It's not giving me that choice. So it will only allow me to multiply. So I put it right next to my 20. And now I've got negative 20t equals negative 40. Now I have to get my number over to the other side because we have to get t by itself. So I drag my negative 20 over. Okay, so now I've got t equals negative 40 divided by negative 20. And we know that when there's a negative on top of a negative, the negatives are going to cancel out, which is good because time can never be negative. So if I double click my line, it gives me a positive 2 as my answer. And since the units up here were meters per second, so we had a 40 meters divided by 20 meters per second, that leaves us with just seconds left. Okay, so I go back to my slides, and under time, my answer was 2 seconds. Okay, and then one last example problem. Go back here. Okay, so you travel at 16 meters per second north. So in this case, my velocity, because it's meters per second, is 16 meters per second, and it's north, so it's positive. North is always positive. And then it says for 60 seconds. That seconds is telling us that that is a time. So we got to go back over here and we put 60 seconds in for the time. So the only thing we're missing is the delta x. We don't know what the x is. Okay, so go back to Canvas. I got to plug my information in here. Okay, I'm going to say my velocity is equal to 16. And my time, t, equals 60. I'm going to arrange them again just so it looks pretty. Okay, and then hit transform again. And we're going to be using the same formula. Now the formula is missing here, so I could just drag that down a little bit, and there's my formula. And I can drag that over to put my formula in. So that way it's there for us. So now I can just do the math. I just plug in, I take my my v here, plug it in for my v there. I take my time, plug it in for my time here. Okay, and then get rid of my parentheses. And we need to move the 60. We need x by itself, so I'm going to multiply 60 by both sides by bringing it over to the other side. So now it's telling me 16 times 60. So I can double click on the multiplication symbol in the middle, and it gives me my answer. So my displacement was 960 meters. So I'll go back into my sheet here, and it's 960 meters. And there it is. So that is how we use graspable math to be able to solve our problems. Okay. So now you guys have, what is it? You guys now have 8 problems to work on your own. And I will send also a link to the graspable math that has these problems in there for you. I'll do it the same way. You'll have some of the information on some of them, and then other information you have to kind of follow along and enter it yourself. So good luck.